This episode of Around the Layout is brought to you by Spring Creek Model Trains. Family owned for nearly 25 years, Spring Creek is your destination for model trains. Check out springcreekmodeltrains.com for a wide variety of offerings from today's top manufacturers and exclusive products found nowhere else. Whether in Deschler, Nebraska, or at a train show near you, stop in and say, wow. To see where they'll be next, visit their website at springcreekmodeltrains.com. Find out how simple and affordable it is to get your model railroad product or service in front of our growing and amazingly engaged audience. Email us at aroundthelayout@gmail.com. Hello, everybody, and welcome to Around the Layout, where model railroaders come to tell their story. My name is Ray Arnott. So glad you could join us. On this episode, we're going to be talking about LCC. And joining me to do that, Dave Barraza. Dave, welcome to the show.
Hi, thanks for asking me. Pleasure to be here.
Great to have you here. You reached out right about the time we were launching this topic-driven episode that we were going to do monthly, and you mentioned your passion for LCC, and I kind of went, what is LCC? And then we chatted a little bit, and you kind of got me up to speed, but I'm not up to speed at all. And there's a lot that I can learn, and I'm sure there's a lot of other folks out there that would love to know more about layout command control. And I definitely would love to be able to add a lot more things happening on my layout. So I think that may be a good path for me. So awesome to have you here to talk about it.
I'll do my best. I'm still learning about it myself. It's developing minute by minute, day by day.
Awesome. Well, we'll try to get up to speed and do it before everything else changes and we have a whole bunch more to learn. So, but before we do that, why don't you kind of introduce yourself a little bit, Dave, and tell us kind of what you do in the hobby.
I have a layout in the basement. I model the New York and Atlantic Railway operating over the Long Island Railroad in HO scale. I've had 94 operating sessions since the later part of 2020, and I can have a crew over between 3 and 16 depending on who can show up that day, and I can have a fun session either way. So I'm an ops guy. So that's the main focus, but everyone's here to have fun. That's really the bottom line. Ops is the focus, but fun is the goal.
Absolutely. 3 to 16 operators. That's a big crew, 16 operators on your layout.
It's a 30 by 50 basement. It's a 3-deck layout. There's 700 feet of main line of 1, 2, 4, and 6 track main line, so it can take a lot of people, or you can, if I have a small crew, I can just say, you know what, it's Sunday, it's 10 p.m., there's not a lot going on, and we're just going to run freight. I've had some great sessions where people were out of town that grew up on Long Island, moved away, and it was their only chance to see the layout. So I grabbed a couple of my core crew, and I'm like, we're gonna run something for this guy. We're gonna have a session, right? So we just take the freight trains out, and I run the passenger trains around like the old jam cars on the slot car sets to run through and get in the way. And it's good. I didn't anticipate that it was going to be as flexible as it was about crews, but it turned out that it was through careful planning and having a weekend timetable and a weekday timetable. It can be pretty flexible. I'm pretty happy about that because I definitely did not plan for that.
Well, that's definitely awesome. It's really great to be able to have big operating crews, but it's also nice to be able to run it small as well, or even by
I run
yourself.
trains myself.
Yeah, that's awesome.
I absolutely do. I can't understand layout owners who just want to freeze the layout in place. Well, I get the freezing it in place thing because that means you can just have your sessions run nose to tail. I do get that, and I do that. But I always run trains in the middle, even if it's to restage or swap out loads and empties or to test equipment. I built it for me. Everybody else is like, I'm happy they like it too.
That's actually a really good way to look at it. It is for you, and it's got to make you happy. And It's seemingly one of the things that seems to make you happy is the ability to do things that are maybe off the track. And that kind of leads us to LCC and the things that are, supporting all of this fun. So let's go right to the beginning. LCC 101. Tell me, what is the definition of layout command control?
It's a communications protocol. At the very bottom of it, it's a way for things to talk to each other. It's a set of, it's basically an event-driven communication system, but it really is. It's a set of standards that are given to manufacturers, just like DCC standards are given to manufacturers, and it's like so that everybody's products can talk with everybody else's products. And so you can buy from whoever you want to buy from. The number of manufacturers has increased. It's actually doubled in the last couple of years, which is to say there's 4 now. Woo! But there, for a long time it was just Dick Bronson and Railroad Circuits as a true believer, pushing the platform forward. But it's starting to catch on. TCS is involved in it in a big way, but the intent was, when it was adopted by a standard by the NMRA, was that it was going to do for everything other than driving trains what DCC had done for driving trains. We don't even think about the fact, once you see in your online store of choice or hobby shop of choice that it says DCC, it's going to run on your layout. And it doesn't matter who your boosters and command station are from or anything else. If it says DCC, it's going to work. And that's what the intent of the NMRA was like, we're going to adopt this as a standard, and we're going to basically say, yeah, we want to do the same thing, so that a bunch of mom and pop companies will be able to make little things, so that large companies will be able to have all their systems work together. And it's a good thing. And I think people that want LCC to be catching on quickly forget that, there was probably a period of time where DCC was up and going as a standard, and a lot of guys were still running DEC. I think it took longer than we remember for DCC to catch on. My first big layout that I built in my parents' house was a DC block control layout with big control panel with 4 cabs and knobs, and all the controls for all the tortoise machines are all in this giant panel in one place. And so I appreciate what DCC lets me do, to walk around and follow the train as if I was on it. I think we forget.
Yeah, we should.
But it didn't happen overnight with DCC.
So what was your first experience in seeing or understanding LCC? What was your first involvement in, whatever product that it was that brought you to having LCC on your radar?
I went to a clinic at the Portland convention in 2015, I think. And it was Dick Bronson Clinic, and it was basically the status of what was happening with LCC. Sorry, it had just changed from Open LCB, and it was officially adopted by the NMRA as LCC at that point. Or I think it was about to. So a little bit of the backstory was that I began work on my layout in late 2014 and early 2015, and I knew it was going to be big, and I knew it was going to have a signal system because that's what I wanted. And I knew that many guys who were going to have a lot of accessory equipment, like a big signal system, along with DCC. And if you're a LocoNet guy, that you would build a separate LocoNet to take the burden off of the DCC LocoNet. So I was like, well, okay, I have to do that. And to back up just a little further, 2 layouts before that, I had working signals on a layout in my Brooklyn apartment, and I actually watched, with not a lot of signals and not a lot of trains running, I watched the LocoNet get overburdened and crash, and there would be large delays. So, I knew that it was going to be onerous to build a large signal system, and I knew that I wanted one. From an operations perspective, the more the signals can demonstrate the dispatcher's intent, the less radio traffic there is, or paper, or anything else. I knew I wanted that. And so I went to this LCC clinic, and they're talking about, you know, this new architecture that was going to be distributed along the track instead of centralized in a computer. They were talking about an architecture that you didn't have to use a computer to do all the logic. It could all of the little elements along the track could each do their part into animating the signals or switches or whatever you wanted to do. And as a professional signal guy, that's the architecture I'm used to. I'm used to signal bungalows and signal cases at every highway crossing, at every signal location, a couple in every interlocking. And, you know, that's where signal systems make their money, is out on the wayside. It's true that there's big control centers with a lot of dispatchers in one place, but those are only sending out requests and they're only getting indications. They don't actually do anything to protect the safety of people in terms of, no CTC system ever has. So at this clinic in Portland, I instantly saw the architecture that I wanted to use, because it was what I was used to, and I saw the advantages of it rather than running a lot of wire a long distance. If you have every 8 feet or 4 feet an LCC node, which is what they call the modules, then yeah, you have to run wires to switch machines and run wires to signals, and you have to run current coils to the track, but you're only running them to something that's 2, 3, 4 feet away. That's manageable. You know,
Right.
LCC is advertised as the single cable solution, and I mean, they're not saying it's the only wire you're going to need, right? But what they're saying is the backbone of getting everything to talk. Yeah, okay, those are Cat 5 or Cat 6 cables that you plug all in a row and daisy chain them to all the nodes. And you know, having had experience with big control panels in the past, it was just that was my first exposure, and I was all in. I remember going to lunch with Mike Deverell, who was facing a similar situation at a similar point in his layout design for his layout in Gig Harbor, and we just sat down and we're like, this is it, I'm in. Right. So from that point on, I just, you know, I think next time I was at Springfield, Dick Bronson had nodes available, and I bought some. I think I got some serial numbers that are down around 30 or 35. So I'm an early adopter.
Excellent. So just to make sure my understanding is starting to come along, what you're saying is, instead of having one main brain and everything else be dependent upon that one main brain, what you have are brains within these modules or these nodes throughout your layout that basically run this software, or whatever this code, or whatever the better word is, to operate that particular item, whatever it be, whether it be a turnout or a signal or whatnot. Am I starting to grab this?
Yeah, they're like little computers. Instead of having a UNIVAC or an ENIAC or a BAT computer that's in the middle, that's like, you know, the core of everything. There's a bunch of little brains that are alongside the line, like peer to peer, or, you know, many to many. So, and they can all do a lot. They can't do, you know, they're not going to do your taxes for you, but they can do the logic that it takes to get, you know, a light to turn on, or crossing gates to lower, or to drive a servo. You know, and there's the hardware. All the hardware problems were pre-solved. Dick Bronson was really smart. He had an existing suite of products that used a protocol from another manufacturer, and he just took all of the business end of those, the input-output end that could drive tortoises and his block detection system, and he just put LCC on the head end. So he didn't have to develop any new hardware. He just had to put the LCC stuff on a new board that had his existing circuits already on it. So yes, it's a bunch of little computers. Now, the best way to program these is with a computer. There's no lie there. I mean, it's a complicated system, and the last thing you want to do is have the manual open with your pencil out and you're banging CVs, hoping you get it right according to the manual. And if you get one wrong, or you don't have this jumper in the right place, you program the one next door. And I mean, I had done that. You know, like I said, I was 100% Digitrax in the year 2005, and I had a Digitrax signals and block detections and PM42, and it's I use a lot of that stuff still, but not for signaling. Because so there's a little computer that's in every node, and you can pack a lot into a little computer these days. So one thing that is stored on the hardware around the layout. Hey, I used the name of
Hey,
the
look at
podcast.
that. Man,
Drink. So the configuration screen, the screen that'll pop up on your computer to program that device, is stored in the device. Once you have JMRI in your computer, or the Deepwood software, which is the other programming environment, both free. Once you have those, you don't have to have the right version of the software for this new node that came out, or for this lighting driver from these guys. Once you've got the framework that allows you to program, each node has all the information that it takes to program it in it, and it pulls the screen over the LCC network into your programming computer and opens up the window. And it's a hell of a lot easier to program than banging CVs or trying to do it over the track bus and take all your locomotives off, because every time I got to program my circuit breakers or auto reversers, I always futz up a locomotive somehow. So the LCC is great. The other thing that they allow you to do from the computer is, from time to time, they upgrade the firmware, and you don't have to upgrade the firmware because the products are always really stable. But if it's got a feature that you want in the firmware upgrade, you can just sit at your computer and you can zap every single node on the layout one after another, just sitting at that one computer, eating a sandwich. So again, it's not. I mean, I don't think you can do that with the older stuff.
So it's I guess the kind of comparison is, to me, thinking programming them manually versus that. It's kind of like with DCC, with like, I guess ESU decoder would be a better comparison versus, sitting there with a power cab trying to enter manual CVs, or putting it in ESU loc programmer and being able to have a better interface and a little bit better way of programming. Is that a fair comparison, or am I kind of off the rails here?
You're in the middle. I think you got most of the wheels still on. It's a partial derailment, but whatever you do, don't back up.
Okay.
So I have the loc programmer, and when you have a particular decoder, or let's say you need a sound project, right? You got to pull that off the internet, right? And then every time you start the loc programmer, it's looking for an update, right? Yeah, so a lot of all the windows and information that gets populated in the loc programmer program is coming from somewhere else, and it does pull the sound file and the DCC decoder configuration files out of the decoders, but it's into a framework that it already knows. Whereas imagine if your loc sound decoder had all of the screens in the loc programmer program stored on the chip.
Oh, okay. All right. That's fair enough.
So if you bought the chip, if you bought that particular, let's say you got a loc sound 8, right? And it's your first one, and your computer's not hooked up to the internet, or your computer's busted, or your modem's busted, or you get that first one, the first of the new thing, right? Mm-hmm. Once you put that engine on the programming track, if it was the LCC model, is all the information and program comes out of the device and populates the screen in your computer, so you can program it with exactly the right environment.
So basically self-contained, and that's what these nodes are. They're a self-contained.
Yeah, they can operate alone. In fact, you can actually run one just by itself. Like if you have a grade crossing on your layout, you can do that with about one node. It doesn't have to be on an LCC anything. It can basically just run the approach track and the island track and the gates and the flashers, and you can put all the logic that it takes to do that right in there. I mean, let's say if your layout is dark territory and all you need to animate is the one crossing. Right. That's a great use case. It's also a great first step. And then, let's say, you try one out and you like it and you wait a little while, and let's say you've got another street in your town that needs a crossing, and it's just one track circuit away, one track block away. Well, you can buy, another node to drive that crossing, and now you run your LCC cable in between. And to the extent that those two neighbors need to share information, it can happen right over that LCC bus. You can chain your crossovers together and everybody, you don't need to, the brute force method would be to put in a sensor cell or a block detection coil for every single one and ignore the fact that you had another one nearby. But that's a lot of extra hardware that you don't have to buy, right? The east approach for one crossing is going to be the west approach for the neighbor crossing. So you only need to detect that track once, and it only needs to go to one LCC node. And then when that LCC node sees an occupancy, this is an example of how the protocol works. Like when the input state changes on node A, he just sends out a message to the world that says, I'm node A and I'm sending out this event, right? And so in JMRI, when you program it, you name that event raise track circuit, right?
Mm-hmm.
And so LCC communicates on a number level. So the node sees a number level, but when you're programming the neighbor node, right, you're like, okay, I need to JMRI, find for me the magic secret decoder ring number for raised track circuit, right? And it will, and it knows it because if you program the first node in JMRI, all that stuff is remembered, right? So when you program the next one, it's going to be, if you type in RAY in the screen, it's going to find, okay, well, it's cool. I found it. I know the secret decoder ring number. You never have to write down or memorize this decoder ring number because you named it something that a human can read. That was something that was once they put that into JMRI and they had the ability to sort of keep track of the human names for all of these sensors, made my life a lot easier as a programmer. Because as an early adopter, I did have to do a lot of that kind of stuff about like, okay, what are these magic numbers? Because it was back in the old days of 2016, it was a little bit more difficult to keep track of all this stuff. Now, I mean, I am probably the object of many people's scorn, but I label very few wires underneath the layout. I don't keep very good records at all. I couldn't get AP electrical from the NMRA achievement program because my documentation is terrible. But everything in JMRI pops up in ways that I can find it, and because of my background, I'm really good at troubleshooting. So those two things allow me to slack to a high degree. I mean, honestly, doing neat wiring and tagging everything gets me start to have work trauma. And this is exactly the opposite of the reason I want to do a hobby. I want to get rid of I need therapy for work.
Yeah, well, if you're held to that higher standard at work and you want to come home and have fun, you definitely don't want to be underneath there with the label maker labeling every single wire.
Yeah, I mean, it's not a rat's nest, but at the same time, it's all the same color wire and there's no tags. Don't ever do that.
So when you talk about these nodes when you use the example of crossing gates, and I can kind of see how they would have to talk together. But for track signaling, I imagine they have to talk together, right? Because I mean, there's certain aspects. I mean, obviously, if you know you're knocking down signals, you need to be able to know what the next signal or the prior signal or et cetera. And that's how it's doing it. It's just one cable just running to all of them and basically having basically declaring, hey, I'm this. And then the next one says, well, if this is this, then I'm this. Right. And I'm thinking, because back in the day, I took basic and then I was in a technical support company for basic. So in my mind, I kind of run basic software in my head, but it's probably a little different, but I can kind of see how that may happen where they're just kind of talking to each other in programming language down the line.
That's exactly how the prototype works, and that's exactly how LCC works. Each, you talk about those signal cases or bungalows along the track. So, a bungalow with a signal at it is going to have apparatus that gives it the status of the tracks immediately in advance of it. And then there's, at the end of that track block, there's going to be another signal, and that signal in that location is going to know about what's happening, in front of it. So obviously you go red when there's a train on the track, and then if it clears up, you go to yellow or approach. But then, we don't look 2 tracks ahead to determine whether we should go green. We look at the next signal, right? If your signal is going to go green, we want to know that the signal ahead is yellow. And in so doing, you also prove that track ahead is vacant as well. And that LCC works the same way. It's like, the guy ahead says, I'm yellow, and that gets broadcast to every single node on your layout, and 99.9% of the nodes will do nothing about that. But the guy who needs to know about, which is the signal and approach, he's going to say, "Oh, that guy ahead, he's green or yellow. Cool, I'm going to go green."
Hmm.
Right? Because green just means the signal ahead is better than stop in a simple red, yellow, green system.
So compare that to, there's other systems out there, and I know one of them that we talked about was CATS. So compare using LCC to CATS, and what's the advantage to using LCC instead?
CATS requires you to use a computer, and LCC doesn't. Now I use two computers for my dispatchers because I have a complicated layout, and my layout is 261 CTC, and it's got interlockings and operators and the whole thing. But there is a portion of my layout where it's a simpler signal system, and it literally is 251 current of traffic, or ABS is what you would normally call it. That portion of track the operators can never see because they couldn't see it in reality. They had to track trains on paper. The signals were there just to protect. Those nodes on my layout, they don't ever need a computer to go. I just turn on my layout and they go, and the signals go, stop and proceed, approach, clear, like as they should. And I've never, once I program it, I've never had to touch it again. I just power up the layout and it goes. So with CATS, if you need with CATS or JMRI, the various flavors of signaling that come from JMRI, or CMRI, or there's a couple other programs out there which are fantastic and they do the job, but you got to have a PC up and running. You have to have the computer running because all of the logic is done in the PC itself. So the any devices that are out along the layout just gather information or activate equipment, and it all gets sent to the bat computer in the cave, and that's the one place where all the logic happens. So that, I guess, would be the difference. I love CATS. CATS is fantastic. If Long Island Railroad used Digicon for their control, I'd probably use CATS because it looks like Digicon, and it's all fairly era appropriate for my layout. But one thing CATS does, which I don't need it to do, is it does all the logic. I do all the logic on the outside elsewhere. So Rodney's fantastic, and CATS is fantastic, and I've operated on a lot of layouts that run it, and I've had a great time using it. So I don't want to say that there's one way to do it. I'm just telling you about the way I know and hoping to familiarize people with the LCC way.
Well, I'm sure there's, pros and cons to both. And,
Yeah.
there's applications where CATS works well, where LCC may or may not. And though I don't know enough about LCC to make those judgment calls, but I know in other things that there's always pros and cons to systems. But it seems like, so what you're saying is for LCC, the computer you have acts more like a monitor in a sort of interface, but isn't really the brains of the whole operation.
Correct. Everybody, all the class ones have giant control centers where they've completely consolidated all their dispatches into one place. And the Hermes system that my company makes and the office systems that they use in all those places are fantastically complicated, but they have nothing to do with whether a signal goes red based on a train ahead of it. All that stuff is in the field. And again, as a professional, I wanted to incorporate that same model. I wanted the office to send requests and get indication back. And then those requests are rejected or acknowledged by the field system to clear the signals. So CATS is fantastic. It actually does too much for me. Now, I know I'm a fringe case, and I think one of the great things about CATS is that if you don't know the difference between approach medium and medium approach, it's cooked into the logic there. So as long as you define the environment correctly and accurately, it's going to put prototypical or mostly prototypical aspects up there pretty much right out of the box, as I said, if you configure it correctly.
So we talked about grade crossings. We talked a little bit about signals. What else can LCC do for you on a layout?
There's a lot of facets to the LCC protocol. There's a few that are still not realized in reality, like streaming audio streaming video. It's built in there. You could run your layout PBX off of like LCC PBX. Nobody's done that. But there's a fast clock protocol in there, and Logic Rail now has a version of their fast clock system that's an LCC. And like we throttle, the LCC will put that fast clock time right into your throttle. So now the throttle in your hand will agree with the clock on the wall. So I'll segue into something else that Logic Rail's recently come up, which is a lighting board. A lot of people are getting into lighting right now. I did a little research into this after we talked last time, Ray, and Logic Rail, they're really smart. I mean, the Woodland Scenics lighting system just plugs right into their board. So it's like let's join them. Let's not try and beat them. Let's join them. Everybody loves this stuff. It's a standard connector. If you're a hobbyist, you can get these connectors at DigiKey for short money. So yeah, you just plug it right into their board. So one of the coolest things you can do with layout lighting is have it react to the time of day. So now you've got the LCC fast clock and the LCC lighting protocol working together, right? And if let's say Woodland Scenics comes out with an LCC lighting controller, well, now it's the time protocol and LCC is still going to work. Those products will all work. You can mix and match. Here's the craziest use case that I could come up with when I was leaning way back in my office chair. You could use LCC to do progressive DC cab control without a computer. And so I guess progressive DC cab control for people who are not 50 years old is a thing that was done where Paul Kermit came up with it, among other people, where a computer allocates the cab that's running at block in a DC controlled layout. I operated on a layout in California, Steve Hayes layout in Sonora. It was indistinguishable from DCC. You really had to know what was happening before you realized you weren't running a DC wireless throttle. It was very, very, very well done. But you had to they had like this old DOS 314 machine, which was the one that would run the hardware, and it had a monochrome display, and it was like should have been in a museum, but it was still working. It was still running the layout, and it just allocated the cabs based on occupancy and the direction of the train. It was fantastic. If anybody wanted to do that now, for some reason, you could do that with LCC, no problem. I'm not sure why you would want to, but that is the craziest use case I could think of. So everything else will seem more rational now.
Well, I'm just loving this idea. That's a pretty cool thing. And just like you said, how they're able to, interact in the same language, a fast clock to lighting to, I imagine just whatever, you can get your imagination wrapped around. You could tie that in and I don't even know, trying to think of even examples of, time, just having that time control.
Well,
what
audio
you could possibly do, with audio effects.
You got a schoolhouse on your layout. The bell rings a couple times a day for recess and everything else, right? Got a church, it's going to ring every hour. If you got Big Ben, it's going to do big fancy stuff every quarter hour, an hour, and ring all kinds of stuff. You could tie in obviously it's a no-brainer that you could tie in your squealer to certain track circuits. If you could do something tricky where if you had a length of track and you knew how long that track was, you can do a little time distance math and you could say, well, the squealer should be going at 30 miles an hour now based on the length of time it took the engine to go across that track. Or if he's going slow, you can play a different sound filer in the squealer. Iowa scaled, I challenge you to make this come to reality.
Well, it would in a sense basically be a speedometer if they could if you could figure out the speedometer aspect of it, and
it does a lot right now. There's a lot more that it could do. It's a very robust protocol, and it's got the one thing it has over the older systems. And I'm not faulting the older systems. These were all designed 20 years ago. It's got 10 times the bandwidth of the older legacy control bus systems. So that means that you wouldn't dare think of putting a track phone connection over streaming audio over like LocoNet. You wouldn't dare, right? But LCC has bandwidth. It's got a lot. It's no bandwidth is infinite, but I mean, it's very open ended, and if the one knock, it might be that it's over designed. Stu and Balas, please don't take this the wrong way. It's like it could do so much that it is. I am glad that I don't have to deal with it at a raw protocol level, because it's complicated, right? It's one of these things where it's typical in computing of today. They take all the complicated work away from the applications programmer or the user, and they put it really low down. There's been a team that has done all of that hard work for all of us dumb users, and it's like it's invisible. I don't have to know much about the protocol itself. I just know that here's the ways that I can make it work for me, and that's basically what it should be. I don't want to become a serial protocol expert just to make my layout go.
And I think that goes along with a lot of layout operators. I mean, maybe they heard the first part of this and maybe got a little nervous. Oh, I got to really learn all of this software, and I got to learn how to program it. And I know, but it sounds like a lot of stuff is pretty well available. I mean, as long as you can learn how to plug in a cable and be able to grab some of these modules, it sounds like it's not overly as complicated as one may think.
Yeah, the nitty-gritty details are taken care of. I mean, to be fair, the same was true of LocoNet and the NCE bus as well. I mean, unless you were going to design products that used LocoNet, you didn't have to learn the innards of how it worked. But this is a protocol that will do more. It's commensurately more complicated, but again, it's all taken care of. Don't build an interlocking with 30 switches to start. Just start with an end of siding, start with a crossing, start with the bell in the church. Start with something simple, or just get fast clocks running if that's your cup of tea, if you like to operate that way. It's manageable bytes. I mean, from my standpoint, in 2015 and 2016, all I was doing was getting switches to move. And that was the first thing I learned, right? And then the next thing I learned was how to make the train detection, the block detection, show up on a screen. I have complicated dispatchers panels now, but they started out with just being track and a button for the switch. So it's how do you eat an elephant? One bite at a time, right? It's the best. You can listen to a billion podcasts about LCC. If you're going to figure it out by solving a problem. That's how I figured out everything I know about it, right and wrong, was by solving taking on a project and figuring out how to do it.
What resources are available beyond getting your hands on? And I definitely agree that getting yourself into it and touching, feeling, and getting yourself wrapped around it is a great way to learn. But what are some of the resources that are available out there for somebody that wants to start to learn?
There are a couple of excellent groups.io groups that deal with LCC. One is called Layout Command Control, and that's more of a user level group. That's probably the most helpful one. The other one is called OpenLCB, and you heard me say that once before at the beginning of the podcast when I was talking about the origins of LCC. It's based on a protocol called OpenLCB, Open Layout Control Bus. And so it was that first, and the groups.io group that's called OpenLCB is a little bit more on the nitty-gritty details, engineer end of things. I'm sure, like, if you were going to make a product that had to work and you had to interact properly with the bus, you'd want to go on the groups.io OpenLCB. If you were trying to animate your grade crossing flashers, you want to go on the groups.io Layout Command Control group. Dick Bronson is a prolific giver of clinics, and all of his clinics about LCC and even his LocoNet stuff and building panels and JMRI, all of his clinics are available on his website, rrcircuits.com. So it's that's not a plug, but there's great information there overall about a bunch of stuff. And I mean, Dick and Karen make products. They're good people. You should buy their stuff. I do. But in terms of, they've also just made it a resource for people that want to use the protocol as well.
Goes along with the spirit of the hobby, just all this information sharing, whether it be, scenery or layout construction or whatnot. Now LCC is also still, a part of that bigger model railroad community of sharing ideas and concepts.
Yeah. I mean, it's this hobby has got so many facets. I mean, I'm a bad carpenter. I'm a bad painter. I'm bad at putting on decals. There's a lot. There's a lot of stuff you can be terrible at. And I am in this hobby. And there's a couple things in which you can excel. You just have to know somebody that's good at the other stuff. But this is just one more thing. It's not everybody's cup of tea. Not everybody wants signals or crossings or whatever. Or you might not model something that has any of that stuff. A friend of mine is fond of saying that the Lehigh and Hudson River had only one power operated switch on the whole railroad. Yeah. So if you don't necessarily need this, but if you're interested, the resources are out there.
Well, I just think, going back to the conversation we had with Scott Thornton, you speaking of Iowa Scaled Engineering, and the theater of model railroading and the possibilities that this can bring along to enhance that theater aspect. Like you talked about sounds and sound over time or lighting over time, and be able to bring that full experience to your layout. This is a great way to do it.
The funny thing is that if you're at a layout and it's a really immersive experience like that, you start forgetting about that stuff. If you get so immersed that you basically think that you're in real life, then all of those effects are sort of doing their job. And then you just forget about it and take it for granted.
Yeah.
Wait, why do we do all that again?
It's certainly a lot of fun and the things that you can do. I've got an idea, but I'm not going to share it on the podcast because I want to surprise some people. But I think LCC may be the way for me to make it happen. But yeah, there's really cool, really neat availability to just enhance the experience. Of the things you've done in LCC, what would you say is your favorite thing on your layout that you've done with it?
I mean, position light signals are just cool as shit. I'm sorry. I can never get enough of watching trains move through and watch them knock down the signals. It's just, to me, it's a signature element of my prototype. So it's I mean, I still enjoy it. It's all of the time and effort that went into that for me, I consider to be time well spent because I'm very happy with the end result. Nothing fancier than that.
No, that's super cool. And
I'll say one more thing though. LCC helps me bring my layout to life. It helps me accommodate, crews of people. And something that I also didn't anticipate as a layout owner and host of operating sessions is how much I would enjoy hosting. So for I want to say that LCC helps me have smoother operating sessions, but it's just because there's a signal system, but it also is, it helps me present the layout the way I want, and it helps, I see other people enjoy it. So it's, that's another benefit of all the hard work,
Well, for your New York and Atlantic Railroad, it seems like it brings the realism forward, right? Because it's what that system is on that railroad is what you're using on
those guys. They have to qualify in position light aspects for sure. So it's definitely there. It's a signature element. Like I said, you can't put, in my era, you can't put a color light signal on the main line. I picked my era very carefully, but in my era, you can't put a color light signal on the main line. They just didn't have them. They were all position lights still.
So what I hear you saying is that's how electronics help tell the story of your layout, which leads us to
excellent
the question of the month, nice. Which is, how do electronics help tell the story of your layout? We had folks that have submitted their answer to the question of the month. We've got 3 of them this month that we're going to play, and let's take a listen to them, Dave.
Hi, Ray. This is Devin Jackson from the Mesquite Melt in Palestine, Texas. For the Mesquite Melt, electronics tell the story by signaling through JMRI, by talking detectors on the layout, advises of problems with trains. My working crossing gates let people know that trains are coming. The working blue flags in the shop add a new level of protection to engine maintenance crews. I have background soundtracks, and my Lower Colorado River Authority shops have welders going to work. And I also have squealers in sharp curves. And that's how electronics play a major focus on the mesquite melt. Have a great day, and we love being around the layout.
Well, I'll tell you, what I love is hearing from Devin Jackson. Devin, great to hear from you. And that's a fun layout to be. If you ever make yourself down into Palestine, Texas, Dave, you got to go over and see Devin's. You talk about a story being told. It's in a depot that he built in his backyard. So his shed looks like a depot. And nice. He's got his entire layout in there, and it is awesome. And again, telling the story using electronics.
Yeah, I mean, based on the description, I'm like, yeah, I want to visit that layout.
Yes, you do.
That sounds cool.
And great to hear from you, Devin. All right, let's hear from Paul Cassar.
Paul Cassar from Sydney, Australia. How do electronics help me tell the story of my layout, the Riverbelt line? Not to a great deal, but I have some key components. I have manually operated level crossings. However, I use timer circuits to time out the level crossing to normalise them. Probably the other two main components that I use, I have a DCC Concepts meter that monitors both voltage on the DCC bus bar as well as what current I'm drawing from the system. And the biggest system electronics I use is my proto throttle, which really does tell the story because it enhances on how I operate and makes operations much more realistic. Love the show, Ray, and that executive producer you've got, he's worth every cent.
We're going to have to edit that part out, but yeah, no, great hearing from you, Paul. And some neat stuff going on, and, timing out your grade crossing circuits. I do like that play aspect where you're able to, have something on the fascia to touch, feel, and there's also a neat element to that as well.
I like that he mentioned using it for the back end. In other words, making sure everything is continuing to be okay on the layout. And it's, stuff like that can help you out when there's nothing ever breaks on the layout unless people are over. So, and so having a meter like that set up is, that's something I should probably do so I can keep track of what's going on.
I think layouts are susceptible to carbon dioxide, aren't they? It's like when you get a mass amount of them in the room, that's when everything just starts to go a little funny.
Yeah, it's true. And the crossing timeout is subtle as a Sphinx. I like that.
Yeah, absolutely. All right. Keith Aleo, here we go.
Hi, my name is Keith Aleo, and I'm from Traverse City, Michigan, and I model the Florida East Coast Railway. How do electronics help tell the story of my layout? I use them primarily for lighting buildings, lighting interior and exterior, and it just adds an overall glow and aura to the scenes.
Yeah, kind of like we were talking about, adding lighting effects and, seeing lights dim and come back up again just brings you right into the realism of the layout.
Yeah, it's a tip off about time of day and stuff like that. It just makes it more immersive. Cool.
Yeah, absolutely. Well, those three gentlemen, I want to thank them for submitting their answers for the question of the month. We'll have a new question of the month next month. You can find that at aroundthelayout.com/question. Scroll down, you'll see the question, and then you hit the record button. You record your answer, send it in, and you may just hear yourself answering the question of the month here on the podcast. Well, Dave, I think I may understand just a little bit more about LCC than when we started about an hour ago.
Despite me.
No, they don't. Thanks to you, and thanks to you coming on and sharing your passion for this. And, it's just amazing the many outlets that our hobby has, whether we talked about painting scenery, layout construction, and then now there's something for the folks like you that absolutely love the technology side and being able to use protocols like LCC to be able to bring a different aspect and bring more realism to their layouts.
Yeah, I couldn't have gotten as far as I did, as fast as I did with the signaling without LCC being there to do the grunt work for me.
Awesome stuff. Well, we will share a bunch of links to help you learn a bit more about LCC and those resources we talked about. You can find that at aroundthelayout.com/128. Dave, want to thank you for coming on Around the Layout and giving us all a little bit of education tonight.
No problem. See you soon.
Thank you for joining us for this episode of Around the Layout. Learn more about today's episode, check out past shows, and much more on our website, aroundthelayout.com. Show your support by becoming an operating crew member at aroundthelayout.com/crew. Follow us on social media, aroundthelayout.com/social. And send us your feedback, aroundthelayout@gmail.com. Thanks for hanging out with us around the layout.